So we know a disjunction is P or Q. Well, P or Q is a compound statement. It's got two simple statements. P is one, Q is the other. And I can summarize a truth table for a disjunction. Well, if P is true or Q is true, the result is true. Because out of the two statements, I expect only one of them to be true. Either the first one is true or the second one is true. So the result will be true. Going along, same logic, first one's false, second one's true, result is true. First statement is true, second is false, the result is true. First statement is false, second is false, the result is false. So an or statement, an statement, they are pretty closely related, as you can see. Let's start with a simple example. Two is an even prime number. Two is in fact the only even prime number. Q laptops require electricity. Well, true. The second statement is also true. One may say, oh, what if I have a magic laptop that runs on just battery? Well, battery has electricity in it, right? So both of them are true. So if someone comes up to me and says, 2 is an even prime number, or laptops require electricity, the result is true. Because I'm going to agree with that statement, because I want either this to be true or that to be true. And in this case, both of them are true, so the answer is true. Case number 2. P has to be false, Q has to be true. Let's come up with a false statement. Trees are animals. Y equals x plus 1 is a, well, that might be a bit too tricky for now. 5 is an odd number. We know trees are not animals, so that's a false statement. 5 is an odd number, that's a true statement. And if someone comes up to me and says, trees are animals, or 5 is an odd number, I simply want one of the two statements to be true, which would make my final conclusion to be true. So, true. And so here is my example for case 3. Caffeine is addictive. Oh, my bad. Caffeine is not addictive because we're doing case. Oh no, I am doing case 3, my bad. Caffeine is addictive. Tea does not contain caffeine. So we know that caffeine is addictive. Think of all the people standing in front of Dunkin' Donuts and Starbucks. And you could see the agitation in their eyes while they're waiting because they want that caffeine fix in the morning. So caffeine is addictive. Tea does not contain caffeine. Well, that's wrong. Tea does have caffeine, but it just doesn't have the same amount as coffee, the levels we drink. So if someone comes up to me and says, caffeine is addictive, or tea does not contain caffeine, overall, the statement is false because one of them is false. Doesn't matter which. Oh, did I say false? I meant to say true. Overall, the statement is true because I just want one of them to be true. Either caffeine is addictive or tea doesn't contain caffeine. One of them is true, the result would be true because I am speaking the truth. All I want is one of the statements to be true. So, I'm going to start with statement P. I'm going to say that coffee is not addictive. Q, coffee is not a stimulant. Both statements are false. We know caffeine is addictive. We know caffeine stimulates the mind. So false, false. And if someone comes up to me and says, well, coffee is not addictive, or coffee is not a stimulant, overall, I am making a false statement. So the result here is false. So the conclusion with a disjunction is in order to get a truth value of true in a disjunction, I would simply want one of the two statements to be true. If one of the two statements is true, then overall the result is true.